For example, the problem statement. The axial displacement du of an elemental length dx of the bar shown in figure 5 under the load P is given by, so given to you the equation. So delta U over delta X is equal sigma over E is equal P over EA, where E is a Young modulus and A is the cross-sectional area. Determine the axial displacement of the bar for the following data. So we understand that the axial displacement is delta U. Okay, the axial displacement is delta U. So you must determine the axial displacement based on this equation. So we understand that delta U over delta X is equal P over EA. Okay, so we have this value, and then we also have area value. Okay, area value. If you want to do calculus, so you just need to integrate. Okay, so you go to this dx, okay, and then you put integration. So, but what is the limit? If you use calculus, you must set integration a to b for the function dx. So what is the limit? What is the limit? Okay, so when you don't have limit, so it means that you need to guess your limit, so that is infinite. Okay, when your limit is infinite, then we suggest you to use numerical integration. Okay, numerical integration. So now we need to see how can we convince this engineering application using numerical integration. Okay, before we solve this one, I need to teach you how the specific method to solve the numerical integration. Okay. So this is the first rule we call as Newton-Cotes formula, first method, rectangular rule. Okay. If we have function or data fx, we can approximate using a series of piecewise polynomial. So this is we call as equal space. Okay, equal space. And our equal space now, the shape is rectangular. Okay, rectangular. So the range of the integration between the a to the b is divided into a finite number of n of equal interval. Okay, equal space is basically equal interval. Width of each interval we can calculate as h equal delta x is equal b upper boundary minus lower boundary divide how many number of equal space? Okay, how many number? Equal space. Okay, if you want to set your number of equal space high, it means that your accuracy will high, but you need to take more time to convert. If you reduce your value of equal space, then your accuracy will reduce. Your computational time will short. Okay? So you need to highlight this formula in your textbook or module. Please highlight, everyone. Okay, how to divide your finite numbers of equal segment b minus a over n. Okay, so now this is we call as discrete point or node in the range of integration is given by this value. So it's basically reflects to our value of x is equal from the initial start A here plus IH. I is the number of iteration, H is increment value. So for every iterative, it's basically how many number of equal space. If you have 1, 2, 3, 4, 5, 6. So it means that 6 and equal 6. So you need to repeat 6 times. 6 times number of iteration. Okay, number of iteration. Okay. Boleh faham? 1, 2, 3. And then the value of age, must consistent. It means that same. Okay. If you cut this one, if you cut n equal to 6, so it means that if you have b value is 10, a is 2, so 10 minus 2 divide 6. So your h value consistent, same. Okay, so this is 8 over 6. So this is 8 over 6, 8 over 6, 8 over 6, 8 over 6, and so on. So your h value is same. H value is same. And then H value or delta X we call as step size. Okay, step size. We also known as step size or increment or equal space size. Okay. When we use rectangular rule, okay, so the shape that we cut for area under the curve is the shape of rectangular. So this is what I mean, okay, rectangular shape. Okay, rectangular shape. Okay, if you use rectangular shape, your shape must cut into rectangular form. Okay. So what is the big problem when you use rectangular form? When you use rectangular rule, so you can involve the underestimate and overestimate the actual value of your integration. So if you estimate using rectangular rule over the fx, so this value will overestimate. If you use rectangular rule and then set below of the function, then your value is underestimate. Okay, underestimate value. This is overestimate value. Okay, so both condition, overestimation or underestimation, is basically will reduce the accuracy of this rectangular rule. Okay, so this is example of rectangular rule. So how can we calculate I? I is the total value of integration. So you must understand that for each border of line, so you have function value because this is a function fx. Okay, so this line is basically, okay, function at x naught. Okay, and then continue function fi. Here is fi. Here is fi plus 1 divide 2. You must divide 2, then the value will little bit increase the accuracy. If you not divide 2, your rectangular rule will reduce the accuracy. Okay, so divide 2. And then you increase again. So this border is basically fi plus fi plus 2. Here, fi plus 2. And then you increase, so this is fi plus 3. Here, fi plus 4, and so on. Okay, so when we combine, Okay, when we combine for all function to produce I total, so the general equation using rectangular rule is this equation. Okay, so first, the integration total value is approximate. So this is approximation value. Is approximate B, the upper boundary, B minus A, okay, divide, okay, divide, you may use divide n, okay, divide n, so it's reflect to determine your H value, okay, H value, and then multiply function at x0, because this is x0, okay, reflect to this figure, this is x0, okay, multiply function at x0 value plus 2. Why 2? Because we need to have both sides, okay, both sides. This is x1, this is x2, this is x3, this is x4, x5, x6. So for every line here, we involve fi again. So it's a double fi. Okay, this is fi, this is fi. So when we come at this point at 1, so it's basically 2 fi. Okay, 2 fi. Okay, so fi start means x1 here, x1. Okay, you just need to add. Okay, plus fxn. So what is your fxn? So fx6. Okay, fx6. And if you have x10, so your function x10, divide 2. Divide 2. Why divide 2? Because here, okay, you want to set the average value using rectangular rule. So you must divide 2. So that is the reason why you divide 2. Okay, if you not do like this, you may directly put n here lah. Okay, so it's basically, this is a summation value. So it's basically the total component value is I total is equal function x naught plus 2. Okay, 2 function x1 plus 2 function x2 plus 2 function x3 plus 2 function x4 plus 2 function x5 plus f x6. So for this overall, divide to n. Okay, divide to n. Okay, saya buat lagi sekali. Okay, divide to n. Don't forget to multiply b minus a. Okay, b minus a. Don't forget to multiply. Okay, so this is in specific. x1, x2, x3, x4, x5. Okay. So what is the function? Function, this line. Function, xx, fx, okay, fx. So whatever function given to you, substitute here. Substitute here, substitute here, substitute, and substitute. After you substitute, insert value x1 here, insert value x2. Again and again, you repeat this process. After that, you calculate all the value, and lastly, you can produce integration total value. Okay, integration total value. Any question? So please highlight this formula using your module or your textbooks. Please highlight. Please make sure that you know how to use this formula. Okay, ada lagi soalan? Tak ada soalan rectangular. Okay, so now let's proceed for trapezoidal rule. So rectangular rule only rectangular shape. So trapezoidal rule using trapezoidal shape. Okay, so it's same as rectangular but only we cut the shape for rectangular. Okay, this one rectangular. Okay, then we believe that using rectangular shape, so the accuracy increase. Okay, the accuracy increase. So the same way as we derive the rectangular shape, the rectangular rule, so same as trapezoidal rule. So we have I1, I2 and so on, but the general equation for trapezoidal rule in order to solve the total integration value is approximate 1 over half, okay, 1 over 2h. What is h? H is step size. That you need to set lah. This is a step size. Okay. And then multiply function node, same as this one. Okay, same This is also function node. This is also function node. So sama. Multiply function node plus 2 function 1 plus 2 function 3 plus 2 function 4. Okay, if you only have, so you end function 4. If you have 10 and function 10. So in between you have 2 function 3, function 4 and so on. Don't forget to multiply 1 over 2h. Because this is a symbol sign, this is a trapezoidal rule. Correct? Trapezoidal rule. Okay, it's slightly different with rectangular. Okay, trapezoidal, they divide terus h over 2. But for rectangular, okay, they divide they divide directly ni dia akan cancel nanti. Okay, so kalau you tengok ni satu-satu ni, dua-dua dia ni dibagi 2. Slightly different. Okay, ni jangan lupa this is for rectangular. So that is for trapezoidal rule. Same method as rectangular but different formula that you need to show using test or project. Okay, so now let's try the example for trapezoidal rule. We would like to feel how can we directly use the trapezoidal rule. Okay, first example. Evaluate the following integral using the trapezoidal quadrature and h equal 0.1. Okay. Arif. Arif. Where Arif?
Yeah, Doctor.
Okay, Arif. Can you give me what is the meaning of the h?
Step size.
Step size. Okay. Okay. Then this is a trapezoidal rule. Can you give me what is the function of x for this example? Function of x. Apa dia?
E power of x power 2.
Okay, ex power 2. This is the function. Good, Arif. Okay. What is the value of lower boundary?
One.
Okay, A is 1, B is
1.6.
Okay, 1.6. Can you determine or calculate what is a value of n? N is a number of equal space. Question mark. N given to you H.
6.
How can you know 6? Okay, Arif said that n equals 6. How can you know?
Sebab H equal to A minus A minus B minus A over N. So kita boleh dapatkan N kat situ.
Okay. Good, Arif. Okay, everyone. Can you understand what Arif tried to explain to us? Yeah? Okay. So now we know that n equals 6. So how many times we need to repeat in order to use trapezoidal rule? Macam mana? So the I total dia nak guna ni kan trapezoidal. So you just need to put H over 2 multiply. Okay, you kena tulis je dulu sebelum you calculate. F0 plus 2F1, okay, plus 2F2 plus 2F3 plus 2F4 plus 2F5 plus F6. Am I right? Am I right?
Yes.
Good, okay. Okay, now what we need to do? What we need to do? Ridwan. What we need to do, Ridwan? 2F5 plus F6. Okay. So now we understand that we have 6. Okay, we have 6 because n equals 6 kan? So F0, F1, F2, F3, F4, F5, F6. Okay, Ridwan, what we need to do after this? What we need to do after this, Ridwan? Kai Wong? Oi, hujan lebat. Everyone hujan lebat ke? Hujan lebat ya? Sini belum hujan. Siapa lagi? Kai Wong. Okay, Rosha dia leave terpaksa leave. Siapa lagi? Any volunteer? Afiq? Aizat? Fatin? Azmi? No sound at all. Are you here? Azmi?
Ya, doktor.
Okay, Azmi kan?
Saya.
Okay, so now I already write all the equation for complete I total. Okay, what we need to do to insert this all value? F0 tu apa? F1 tu apa? Apa? Cuba explain. So how can we determine F0 value?
Not.
F ni apa? F ni apa, Azmi?
F2 function.
Okay, sekarang function kita apa?
Function kita E power of X squared.
Okay. So, F0 kita? F0 kita ni pada X berapa?
X kosong.
Ya ke?
X1.
X1. Okay. We understand that this is X0. X0 kita adalah 1. Faham
Okay.
Okay, so you kena buat macam ni lah. X0 equal 1. Masukkanlah dalam equation. Okay, buat satu-satu. That is the first step. And then yang kedua, function 1. Function 1 berapa? Value dia?
1.1.
Okay, x1 equal 1.1. So you buat exponent 1.1 kuasa 2. Okay, the purpose is we replace the x value tu je. Okay,
Oh,
so you kira lah dapat ni berapa. Berapa Hazmi? Okay, cuba kira. Semua cuba kira. Exponential 0 power 2. Dapat berapa?
dapat 1.
1 juga. Ni nombor 2 ni eksponen 1.1 kuasa 2 ni.
Dapat 3.353.
Okay, so now you need to repeat all the function sehingga F6. After you obtain this value, masukkan dekat sini. 2 kali 1 plus 2 kali 3.3. Faham tak? Boleh imagine tak? Okay, boleh imagine
Boleh.
Okay, so now guys, so for numerical integration is basically suitable for tabulated data. Suitable for tabulated data by setting your equal space. You no longer use ni, simbol ni. You tak guna simbol ni. If you use this symbol, so it's basically you use calculus. Okay, if you use this symbol in order to solve your problem statement in numerical integration, so I will give you 0. 0, 0, 0. Okay, you must show your ability to solve using numerical differentiation. That is the part of cut equal space. Ni cut ni. Okay, andai katalah you boleh draw exponential ni, exponent ni macam ni kan, lebih kurang. Okay, ini benda yang you kerat. Ini function node, ini function 1, ini function 2, ini function 3, ini function 4, function 5, function 5. That is the imagination. How can we solve numerical integration? Siapa yang tak faham? Please mention to me. Okay? So whatever question, whatever problem statement, okay, that gives to student regarding numerical integration, okay, you must understand what is the function, what is the lower boundary, what is the upper boundary, what is the equal space that you need to choose. Okay? The wrong value for the equal space. For example, you set you punya equal space you 1.3333. It will affect the error. Okay? The smallest the step size, the smallest the space ataupun equal space, so it will give the accuracy value. The largest equal space, then you receive your answer by reducing the accuracy value. Okay, that's it. So you try this example 1. Okay, proceed to the example 2. Determine the value of the integration. Okay, integral value I equal to integration from A to B for the function where the function given to you. Okay, so this is the polynomial. So with A boundary, A lower boundary 0, B upper boundary is 1.5, using trapezoidal quadrature with different interval. So different interval means maybe you choose n equal to 5, maybe your friend choose n equal to 3. Okay, how? So H equal B minus A over N. So B is a 1.5, A is 0, and if you choose 5, so your H is 0.3. If you use N equal to 3, so your H is 0.5. Okay, the answer will be different, but very close, very close. Okay. So then you can comment what happened. If you choose 0.3, step size or equal size, so it will reduce the accuracy of the computational. If you use H 0.5, okay, large value, reduce accuracy. If you use H 0.3, so it's been a small gap, so it will increase accuracy. Okay, any question? Understand? Understand? So it's simple, simple for rectangular and trapezoidal. Ada soalan lain? Ada soalan? No? No. So the difficult, okay, the difficult method after this is Simpson. Little bit difficult. Okay, Simpson one-third rule. So I would like to introduce you now is Simpson one-third rule. So the Simpson one-third rule is actually the accurate method compared to the trapezoidal rule. Okay, it improved by increasing number of segment n or reducing step size h, but the latter lead to increase in runoff error. Another way to get more accurate estimate of integral is to use higher order polynomial for approximating the function of fx. Okay, so according to figure A, okay, according to the figure A, so this is only quadratic. So this is a quadratic. This is a polynomial. Okay. If we use a polynomial, so this is a polynomial also. Okay, this is cubic power 3. So maybe we can guess by using a polynomial, it gives high accuracy but difficult to cut the segment. Okay, for example, this is a polynomial. If we cut, okay, it looks like trapezoidal, right? Here looks similar to trapezoidal. Okay, similar to trapezoidal, but if we use trapezoidal, we use the trapezoidal equation like this. We use this trapezoidal rule. Okay, if we use Simpson one-third rule for polynomial, it looks like trapezoidal but different equation. Ingat, different equation with trapezoidal. Ni takut student confused. Different equation. So Simpson produce different equation compared to trapezoidal by increasing number of segments. Okay. What else? Constant A node A1 and A2 can be determined by making the approximating a polynomial, okay, that is equation before pass through 3 consecutive point. Okay, dia ambil 3 consecutive point lah. How they develop the equation for Simpson. Check the original at x1 so that xi minus 1. So it means that previous point before xi. And xi plus 1 correspond to minus h and plus h respectively. And apply them to the polynomial. Okay, so dia dirahlah dapat macam ni. Okay, solving for the A node A1 and A2. So they found that this equation area under the second order polynomial between xi minus 1 and xi plus 1 is given by, so they derive lagi. And then they substitute for A node A1 and A2. After that they produce the average value of the integration is similar as h over 3. H over 3. Because they consider 3 main points. 3 main points. Xi minus 1, Xi, and Xi plus 1. So 3 points. So when they consider 3 points, they must divide with 3. That is the reason why H over 3. H over 3. Okay? And then you must multiply with the function I minus 1. That is a previous point. And then plus 4 Fi plus Fi plus 1. That is the forward point. The term 1/3 in Simpson 1/3 rule refer to the factor of 1/3 because it refers 3 points that they are calculated for. For multi-stage application. We need to divide the range A to the B into n segment of equal with H equal to B minus A over N. So this is same with N being even so that it can apply for group of 2 segments. So usually for Simpson 1/3, okay, we use an even number. Okay, usually Simpson 1/3, we use an equal even number. Okay, therefore, the general equation for the Simpson 1/3 is this formula. Please highlight in your module or your textbook. So the total integration value approximate 1 over 3 multiply H. H is step size. Okay, step size-nya sama saja. H sama dengan B minus A over N. So you need to decide N number, even-nya. It suggests to use even number of N. Multiply F naught plus multiply the total, okay, summation value of the all function. Multiply with 4. So the function only for the odd number 1, 3, 5, 7, 9 and so on. Plus 2 even number 2, 4, 6, 8, 10, 12 and so on. Plus n function. Plus n function. So you need to have 2 different terms. First, F naught. So here is F naught. F1. So you need to use 4F1. 4F2. Oh no, 2F2. 2F2. Okay. 2F2. Sorry. 2F. 2F. Okay, this is F naught. F1 yang ini kan? Yeah. 4F1. 2F2. 4F3. Okay. 2F4. 4F5. 2F6. 4F7. 2F8. 4F9. And the last one, F10. Can you understand? Can you understand? Everyone, can you understand? Can you understand or not?
Yes, Doctor.
Okay, Richmond. Okay. Okay, understand? And then the same way, you need to calculate the value for each function. So after you calculate the function, so just substitute and then calculate for the I total. Okay, that is for Simpson 3.8. Okay. Example. Get me the value of the integral for the function given 0.8488 and so on until x power 5 with a 0 lower boundary and b 1.5 upper boundary using Simpson 1/3 rule with different interval. Okay, any volunteer to explain what is the interval that you want to use? Fakrul Amin. Fakrul Amin. Baik, Fakrul Amin tak ada. Francisca Pawi. Francisca. Ashraf Sharifuddin. Ashraf Sharifudin. Nakib Haziq. Nakib. Hai, Nakib tak ada. Hui Fung. Hui Fung. Saya rekod tahu bila saya panggil ni, saya akan check you punya attendance is about 80% or not. So please mention to me regarding you having problem or not. If not, I consider you are not attend my class. Aizat. Aizat. Aiman. Yan Jingji. Okay, Aizat ada. How many number Aizat you want to use for this example? N numbers. Berapa yang you nak guna? 4. Okay, 4. So 4. So you want to use H equal B minus A over N. So it's basically 1.5 minus 0 divided 4. So what is your H value, Aizat? What is your H value, Aizat? Okay, 0.375. Okay. So after that, we need to write our total integration equation. Okay. First, because of Simpson 1/3, so it's basically 1 over 3 power multiply H. So 4. So first is F naught plus 4F1 plus 2F2 plus 4F3 and then plus F4. Okay, you must write like this and then please recalculate for every function. So F naught is basically F at 0 because we start with a 0. So put in this all equation here. Change your x value first with 0. And then function 1 is basically function at 0.375. Substitute your x with 0.375. Repeat this process for F2 is equal F at 0.7. Betul ke 0.7? 0.375 multiply 2. Berapa? Okay, 75. Yes. And then continue F3 is equal F 1.1 1.1 1.125. Okay, you continue until F4 is basically F1.5. So after you obtain all the value, please substitute here, 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 here. Okay, sum up all H value dia yang ini, sum up all, then you obtain I total. Okay, if you are able to calculate I total, I will give you 8 marks. Okay, 8 marks. Any question? Okay, that is Simpson 1/3 rule. Okay, Simpson 1/3 rule. Okay, any question? Any question? No? Okay, so now this is the last method. or last rule for Newton quotates. We call as Simpson 3-8 rule. Okay. For Simpson 3-8 rule, it's basically use third order polynomial and using same as 1/3. They also use 3 point. Okay. This one, So they want to determine the coefficient for A0, A1, A2, and A3. After they rearrange all the equation, they will produce Fi plus 2 and previous point. So the term 3/8 in Simpson is basically 3/8 term. Okay, so 3/8 term. So for 3/8, you must, okay, the number of segment of n must be multiplied of 3. So that can be applied for group of 3 segment. So 3 lah. 1, 3, 4, 6, 7, 9. So you must understand this. Okay, every 3 multiple layer. Okay, di group 3, 3, 3. So in general, the formula, okay, the formula for Simpson 3/8 is basically I total integration value equal 3/8h multiply f naught plus 3f2 plus 3 plus 3f1 plus 3f2 because this is 1, 1 plus 1, 2. Okay, plus 3f1 plus 3f2 and then plus 2f3 written back plus 3f4 plus 3f5. Go back to 2 segment, plus 2f6. If you already finished, then you may directly jump f7. Okay, f7. That's it. Okay, this is the rule for Simpson 3/8. So usually for Simpson 3/8, we use for odd number of segments. Okay, odd number of segments. Okay, so this is an example for using Simpson 3/8. So the same way as Simpson 1/3, so you just need to apply the formula for Simpson 3/8. So please try by yourself, example. Okay, please try. Senang aja. So you may directly calculate, okay, using your calculator and store the equation. So obtain the value. Okay. So now this is the last rule for numerical integration. We call as Gauss quadrature rule. Okay, mudah saja. What is Gauss quadrature? Gauss quadrature is basically the extension from the trapezoidal rule to calculate area under the straight line connecting the function value at the end of the integration interval. So, if you want to use Gauss quadrature, you must convert from the calculus function to Gauss quadrature term. Okay, Gauss quadrature term. Okay, how can we transform? Where we need to understand where A and B are limit of the integration and B minus A is the integration interval. So yang ni biasa kita buat. So we transform that from the boundary A to the function A, from the boundary B to the function B, and then we divide into 2. Okay, kita divide lah. Because trapezoidal rule must pass through n point. There are cases such as this figure where the formula results in large error. So that is the reason why we use Gauss quadrature. If we use trapezoidal like this, so this is underestimate. Okay, underestimate. If you use trapezoidal over this line, so this is overestimate. If we use a polynomial like this, so we also have underestimation of integral value. Okay. Therefore, Okay, therefore, suppose we take away the constraint of fixed base point and evaluate the area under a straight line joining at any point of the curve, we could define the straight line that would balance the positive and negative error. Figure 5 to arrive at an improved estimate of integral. So what the Gauss quadrature do is, it will cut here, okay, from the original point A and B. So it will cut a little bit small to the inner side of the area. Okay, so this is the area using Gauss quadrature. So means we need to transform point A to the x1, point B to the x2. So same as the second figure, point A to the x1, B to the x2, same as figure 3, point A to the x1, point B to the x2. So how can we transform? That is our question mark. Okay, how can we transform? The domain of the integral for this rule is conventionally taken as -1 to 1. So it means that x1 is -1. X2 is 1. So we need to set consistent. This one also, x1 is a -1, x2 is 1. So this figure also, x1 is a -1, x2 is 1. Okay, so we need to set a consistent value. Taken as a -1 and 1 to simplify the mathematics and make formulation as general as possible. So because we would like to set as general as possible, we don't want to have point form. We want to dimensionalize the value from A to the B to the x1 to the x2. A change of the variable is used to translate the original point A and B integration limit into -1 to 1 form. Okay, so we transform from the A to the -1, B to the 1. So it can approximate using the weightage. So when we transform, so it's basically the summation value of this iteration where put weightage multiply function xi. Okay, where we understand that wi are unknown as coefficient or weightage. Okay, weight or weightage. I, xi are specific value of x called Gauss point at which integral is evaluated. Okay. Okay, so what we actually do using Gauss quadrature. First, we receive this function. First kali ya. So we receive this function with the boundary A to the B. And then we need to transform. So this is first step, receive. Okay, we receive this equation. Okay, we receive function with the boundary A to the B. And then the second step, transform. Because we would like to transform to the dimensionless value from A to the -1, B to the 1. Okay, transform. How can we transform? Okay, transform using the specific equation. So please use this equation. Highlight in your module or textbook this equation. So if you want to transform this x is equal b plus a plus b minus a multiply xd. Xd means transformation. Okay, transform medium. Okay, medium. Because from the original one, we transform to the weightage. Okay, weightage. And then divide 2. So B is upper boundary value, A is a lower boundary value, B is upper boundary value, A is a lower boundary value. Only directly put the value and then solve this one. Okay, solve this one. When you solve this one, so you will produce new equation. Okay, new equation. So remain that equation, you must change x with this new equation. So you akan dapatlah x equal 0.4, okay, something plus 0.4. This is example, yeah, xd, for example. So this is a new equation, yeah, new equation. So after that, this one, third step. step. So it's automatically, when you use this formula, it's automatically changed from -1 to the 1. So it's a function x. So now your x, this is all x. Ini ya, x. X d dx. Okay? So your total integration is fx d dx. So you masukkan balik d dx. Sama formula ini sama. Therefore, simplified of this equation, you bring out b minus a. So you keluarkan b minus a over 2. So you only need to care from a -1 to the 1 function of x d dx. Okay? When given the function, okay, so this value need to change based on function given to you. Okay, function given to you. And add weightage. Macam mana weightage ni? Okay, so this is the step number 2. Step 2, transform Okay, ni you transform. Equation ni sama dengan equation ni. Ni sama dengan equation ni. And then differentiating give. So bila you dapat ini, okay, you add this one additional equation for differentiating. So dx equal b minus a over 2 d dx. Yang ni yang mana? Yang ini. Nah ini. This term. Nampak ni b minus a over 2. Sama Yang ni Okay. And then you need to decide how many points. So for you guys, so I will teach you only for 2-point Gauss quadrature. Even though outside of this knowledge, they have a lot of points, 3 point, 4 point, 10 point, until up to 1,000 point of Gauss quadrature. So I only teach you 2 points because this is a fundamental. How can we start with the lower point? Okay, which is 2 point. Okay, 2 point. So after you transform this kind of transformation, -1 to the 1 function of dx. So 2 point means you must multiply with the weightage 2 times. So weighted 1 and weighted 2. If you have 3 point, so your weightage is 3. If you have 4 point, your weightage is 4. And so on. Since n equal to 2. N equal to 2 reflect to the point lah. 2 point lah. N equal to 3, 3 point. Okay, that is not same as Newton quotics. Newton quotics, n is a number of equal space. Then you calculate to obtain step size. For Gauss quadrature, n is basically how many points you want to use. Okay, so since 2 point is n equal to 2, the formula should give abstract value for polynomial or order 3 and below. And we extend this reasoning by assuming that it's fit to the integral of fx, 1, x2, x3, and x3 function and so on. Okay, for higher point, you ada kena tambah lah, banyak weightage ya, sampai omega n. Okay, in general, in order to make sure that this is easy to solve, so whenever you want to use Gauss legendre, so you just need to refer this table. You need to refer this table. If you use 2 point, your weightage that you need to multiply is only 1. Okay, you kali satu-satu je, so no meaning salah. And then your x value, x1 value that you need to change is a minus 0.577. For x2 is a positive 0.577. Where is there's a value that you need to change? Here. You nampak tak ni? Ini kan? Nampak ni kan? Okay. After you produce new equation that I mentioned to you just now, here. Okay. After you produce this equation, so you insert this equation here. So in this equation, you have x term. So this x term change. Okay. Bila this x term, you kembangkan dia jadi macam ni kan? So this x1 term, this x1 term, use minus 0.577. So for Gauss quadrature, no value from your sub. You must directly apply the value from the table. So as x2, so this one minus 0.577. So this is minus, this is a positive. Okay, if 3 point, multiply with the 1, 2, 3 weightage, and then your x value must follow. X1 is a minus 0.77, x2 is a minus 0, x3 is a plus 7. So you follow lah for others point, 4 point and 5. Okay, so example 7.3. So this is show how Gauss quadrature can be solved. Okay, given function like this, integrate the function between a0 to the b 0.8. Okay, first step that I teach you. First step, what we should do? Okay, first step, you receive this from question. Okay, you receive this from question, and then transform. I mentioned to you transform. Okay, transform b plus a plus b minus a. Directly apply that equation. Okay, b plus a, okay, plus b minus a. Divide 2, betul? This one dxd, betul? So this is x. Ya? Ya, sama R tu di dx lah. Ya, dxd. xd. Okay? Ya, xd. Okay. So apa dia? B berapa? B adalah 0.8 tambah 0. Okay, plus B 0.8 minus 0. So bagi 2, xd. So the new equation is basically 0x equal 0.4, okay, plus 0.4 xd. Okay, new equation. Betul New equation. Okay, new equation. After that, you know this new equation you must insert. Okay, second step. Apa dia? Saya cakap. After you use this formula, it's basically change to the minus 1 to the 1. Kan? You dah ni, you dah jadi macam ni, so maksudnya ini term you lah, new term. Okay, new term. So, dia akan jadi ni, you akan boleh buat macam ni. Gini, minus 1, 1, ni function ni tadi. Okay, function ni 0.4 plus 0.4 xd. Okay ni xd. dxd samalah. So untuk solution ini dia keluarkan 0.4. So dia keluarkan 0.4. After it move out di 0.4, so dia change kepada weightage. Directly change the weightage. Okay, change the weightage. Here. After you transform, okay, yang ni sama dengan ni kan. After you transform minus 1 to the 1 is basically same as the summation value for all weightage. So if you want to use 2 point, so W1 Fx1 tambah W2 Fx2. Itu saja. Okay, so yang ni dia pakai 3 point. So 0.4 C naught Fd X naught. Okay, C1 COW lah. Sama weightage. Fd X1 plus C2 Fd X2. Okay, dalam kategori ini you boleh juga buat. Yang ini adalah C1, 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 C2, C2, C3, C3. Kalau you nak guna table ni. Okay, 1, 2, 3, 1, 2, 3. So sama lah. No problem at all. So 0.4 weightage 0.555. Yang mana? Ni. Masukkan weightage dia dulu. Ini weightage kedua, ni weightage ketiga. So yang dia buat, weightage 1, weightage 2, weightage 3. Okay, dia bubuh dulu weightage. However, yang ini belum lagi selesai. Okay, this will reflect. This one is, mana table dia? Negative 0.77. Okay, please insert this one 0.77. Negative 0.77 inside here. Negative 0.77, negative 0.7, negative 0.7. So for this one is 0. 0. Insert 0, 0, 0, 0, 0. And then again for the third value is 0.777. 0.77777. After that, solve for the I in total, you may obtain 1.64055. Correct. I will give you 5-point mark. Any question? Any question? It's not too hard. If you follow one by one, then you can understand enough for numerical differentiation and numerical integration. Not too hard compared to others topic yang masa test 1. Any question? Any question?
Doktor, untuk
Yes?
untuk question contoh macam yang tadi tu kita boleh pilih lah poin berapa kita nak guna. Poin 2,
Yes.
poin 3.
Yes. If test, during test, if question want you to use any kind of point, you may choose 2 point, 3 point. Okay? No problem. Tapi kena betul lah cara you masuk. Kalau you nak guna 2 point, yang ini jadi 3, salah lah. Faham kan? Okay? So I hope you may try again and again this example for Gauss quadrature before we understand everything for numerical integration. So I want you to use and try this example. Okay, evaluate the integral below the Gauss Legendre quadrature. Try this one and then the second example. Try by yourself, yeah? Try by yourself. So usually this example is easy. If you're not sure, please directly ask me. Okay? Okay, that's it. This is all about the numerical integration rule. For Newton context, rectangular, trapezoidal, Simpson 1/3, Simpson 3/8, and Gauss Legendre. 5 rule for numerical integration. For sure, it will test during test 2. For sure. Okay, it will combine with the numerical differentiation and curve fitting. Okay, assignment 5. We'll check in e-learning. If any changing about the assignment, I will let you know. Okay, I will let you know. Okay, so before I end for class today, I would like you to know what is actually about the project. Okay, project. So we are in this course is actually need to have some modification. Okay, some modification about the marks and so on lah. So I need to explain to all of you. Okay, so I need to close this one. Okay. So I would like to share another content. Yeah. It's actually share this one and then a project. Okay. Can you see? Can you see my PDF file? Can you see everyone my PDF file?
Can, Doctor.
Yes, Doctor.
Okay, can you see? Yeah? Okay, now what we are going to do is actually this is for project grading rubric. Additional information from our coordinator. Okay, I already assigned you project 1. It's about regression. Okay, which means curve fitting lah. Curve fitting, regression, and numerical differentiation. And I also write down what is actually my hope to my student, what you need to submit for your project to me. And of course, project for your section I will mark. Okay, it's not same as test. Test, others lecturer marks to you. Okay, for project, I need to correspond to all of you. So, in order to make sure that all students need to take into consideration for all values for the project, so I need to mention to you clearly again. Okay, clearly again. So it's similar to what I already explained to you for project, okay, for project, but just little bit. So this one, okay, this one is actually, I will implement for the project number 2. So because I already released for the project 1 individual, so you need to continue individual, okay, for project 1. Continue with individual. For project 2 that I will assign to you, okay, by next week maybe, so it must in group. It must in group, but not more than 2. Compulsory only 2 students. Only 2 students. Okay? So after finish today class, you need to decide and then inform me. I will group with this one, doctor. I will group with this guy, with this member and so on. Okay. So this is a rubric. So you must mention your group. Okay? Tak kisahlah group nama ke, group name ke, group apa. It's about your understanding with your friend. Okay? So, before you submit your project report, you must put this rubric in front. Okay, you have cover page. Okay, cover page of your project. And then the second page, this rubric. And then after that, when I open, I will give marks on this page. Okay, on this page. Okay, so what I intention to see? Derive and explain the governing equation. Okay, you must show your derivation and explain your governing equation. It also same as your project 1. I also want to know what is actually the governing equation that you use in order to solve your project. Okay, so the weightage for this part is about 0.2. So I will give score from 1 to 5. Okay, then I put marks. And then you must discuss and explain how to solve the governing equation analytically. Okay, because you need to have comparison between the numerical and the analytical. For example, just now I explained to you the numerical integration. So numerical integration based on the calculus, that is the analytic. Okay, instead of calculus, so you use a Simpson, you use trapezoidal, that is a numerical integration method. That is a numerical integration method. I always explain that, okay, except numerical method, so that is the calculus method. So calculus method is the analytical solution. Okay, so the weightage is about 0.2 lah. And then solving the governing equation using appropriate numerical method. That is the reason why I give you freedom for my project 1. You can explore whatever method that you want. Okay, you can use a backward with a second order accuracy. Forward, you need to think what is the suitable appropriate numerical method that you need to solve, you need to use to solve the problem. Okay, it is up to you, freedom. When you use the specific numerical method, so please discuss in a proper way. Okay, because we would like to make sure that all the students able to discuss, to do the discussion. When you do the discussion, so please make sure that your discussion using a passive voice sentences. Passive voice sentences, not an active voice. Okay, you need to train yourself because by next year, you need to do your final project. Okay, undergraduate final project. So you need to start now how to write good report project. Okay, so discuss and explain all the steps in solving the problem numerically. Okay, you need to discuss, explain what is the step. Step number 1, step number 2, what you need to do. Because for this project number 2, it's actually 2%. Okay, 2%. And then CLO3. So it's basically develop a well-structured and reliable computer programming. So you have 2 students, okay, in a group. So you need to develop your own coding. Make sure that you use Octave. Do not use Toolbox. Okay. Then I need to check your coding. If not able to run, so your mark will reduce. If your coding, okay, able to run, then your marks will high. When you use, okay, when you use a proper numerical and then you able to discuss and explain the computer algorithm or chosen numerical method, then your marks will increase lah. And then you must discuss and explain the programming flowchart. Okay, you do make your own flowchart properly. So I believe that you already learned during your programming for engineer how you can do your flowchart and so on for solving problem using programming, right? And then coding successful and program must run. Okay, must run able to receive any kind of output. When you obtain your output, please discuss your output. What happened to your output? How about the error? How about the error comparison with the analytically and others method about the error? Okay, anything you can discuss and then fully comment on your source code in detail. Okay, in detail. And then you need to analyze about the validity and accuracy of the numerical solution. You may compare between the method, compare with the calculus method, and so on. So when you discuss, you need to refer to the figure, refer to the table. So please use a proper caption. Proper caption. Okay, again, proper caption. If not, when I read your report, I'm not sure where is your figure or table. Do not forget to put reference when you do complete report. References. Please make sure that your references refer to the UTM thesis format. Okay, references. Use it correctly. Don't put directly. Name of author. Okay. Please put name of author correctly. And then the title of the book, title of the journal, and so on. Properly. Okay. So I will share this project grading break to you, okay, after I release the project number 2. So please bear in mind now your project number 2 end by this month. Okay. Saya cakap end of this month kan? Project number 2. If I'm not mistaken. So I will release next week, inshallah, for project number 2. So don't worry, project number 2 is basically from the previous topic. Okay, from the previous topic. And then I will not teach you about PDE because we are agree for this semester we not teach about the PDE. Okay, please ignore PDE and then I will pull down project number 2 in e-learning. So I will change with a new project. Okay, understand all? Understand? Understand? So before you submit your project number 1, so you also need to put this rubric, okay, in front of first cover letter, your name and everything, and then second page, please put this one as your rubric. I will directly insert in this page. Okay? Any question or you still confused about the project 1? Any question? Any question? And then I hope for this section, there is no student drop this course. No student drop this course. I tengok about 20 students. So where is the more 8 students? So they are dropped already? You know who is your friend drop this course? You're not sure, only 20 students. Or they still celebrate Hari Raya? They still celebrate Hari Raya? Oh, I don't know. Okay, so never mind. Any question before we stop?
Doctor,
Yes.
I would like to ask if this programming need to use Octave or can we use MATLAB also? to complete the
Okay.
project.
So for you guys, project number 1 is a freedom. You may use directly any kind of solver. For project 2 that I will assign by next week. So our course coordinator want every student use Octave only and do not use Toolbox. You just can use Octave. Is it okay? So whatever happen, you need to learn a little bit for using Octave. Because this is also free version, so it's convenient for all students. So nowadays, we try to convince all students to use a free version software. Okay, it's benefit for you. Okay, instead of you try to search for the license, UTM license, waiting for UTM license because you are now in your hometown and so on. So we are not able to help all students. We just can suggest for all students, please use open source version solver. That is beneficial for you. Okay, try by yourself because this is 2 person in a group to solve project. So make sure you choose your friend properly. Okay. Okay. So later on, I will check the attendance. So how many of students still remain in my section? Then I will guess. Okay, you may be couple, yeah, for solving the project too. So later on, I will update to you. Is it okay if I give groups instead of you are searching for your friend? If not, I will assign. Can I give? Can I give a group? Only 2 of you. You may search, okay, and inform me. Okay, and inform me. For others, if you are not able to search friend, then I will assign. Okay, I will assign. Tengok keadaan. Mana yang dah ada geng-geng tu, saya tak kacau lah. Yang mana tak ada macam senyap, tak nak tanya tu semua, then I will assign. Okay. So I hope you can submit project number 1 by end of this month. Okay, before you submit, I will send project 2 because we don't have more time. So I need to release at least 1 month in order to complete project number 2. Okay, so any other question? Maybe last question before I stop. Okay, so don't worry, whatever marks that you receive for the test 1, so not only for our section, so it's same for all section. It's average. Okay, it average. That is a similar situation for the previous semester. For numerical differentiation, for numerical method, so it's basically many of students able to pass, but difficult to score. Okay, I really would like to mention to all students, so don't upset. So you can try for your second test, score for your second test, and of course, you can score for the project and assignment. Inshallah, okay? So you can do it better for second test. Doctor, project 1 last time you mentioned, oh, okay, June tak boleh, June lambat sangat. Only 1 month, approximate 1 month. Okay, when I release the date I release the project 1, so you approximate 1 month. Okay, 1 month. So maybe ada kesilapan 4 Jun terlalu lama. Okay, 4 Jun terlalu lama. So by end of this month, ya. Lambat tu. Okay. So coordinator dia nak dalam 3 minggu saja. So saya bagi lebih kurang lah sehingga hujung bulan ini. Okay, no question? Okay, so if you don't have any questions, so I would like to stop for our lecture today. So please continue your project because you have extra 30 minutes with me. Okay, spend your time to solve project 1, do it coding and so on, complete your report properly. So I would suggest you, if you don't have idea how to write the thesis, how to write your project, so please refer UTM thesis format. That is a good example how you can start writing your project. Okay. So if you don't have question, thank you very much for joining my lecture today. And I hope we'll see you next week. Okay, Assalamualaikum dan jumpa lagi.